Many people think a war tank is basically an armored car with a cannon on top. But in reality, the engineering behind a modern tank is much more complex than it seems. And understanding how it actually works completely changes the way you see these machines. Let's start with the armor. Most people imagine that a tank is simply a box made of very thick steel, but that isn't true. Modern tanks use what engineers call composite armor, which is basically a sandwich of different materials stacked in layers. The most famous tank in the world today, the M1A2 Abrams, uses a combination of steel, ceramics, and other materials classified as military secrets. Each layer has a specific function. Ceramics, for example, are extremely hard but also brittle. When a projectile hits them, they fracture in a controlled way, absorbing and dispersing the impact energy before it reaches the inner steel. Because of this, composite armor protects much more effectively than a solid steel plate of the same weight ever could. But armor alone is not enough. The most modern tanks also have a system called explosive reactive armor. These are small blocks attached to the outside of the tank that contain explosive material. When an enemy projectile hits them, they explode outward in a controlled way. This explosion directly interferes with the projectile, destroying or deflecting it before it reaches the main armor. It's basically the tank actively defending itself at the exact moment of impact. Now let's talk about the cannon, and this is where things get even more impressive. The main cannon of a modern tank doesn't use ordinary gunpowder. It uses extremely powerful chemical propellants that create enormous pressure inside the barrel in less than a millisecond. This accelerates the projectile to a speed of about 1.8 kilometers per second. To give you a real sense of what that means, the speed of sound in air is about 340 meters per second. A tank projectile leaves the barrel traveling more than 5 times that speed. And the projectile itself doesn't work the way most people imagine. There is a specific type used against other tanks called a kinetic energy penetrator. It doesn't explode. It looks like a long, thin dart made of extremely dense materials such as tungsten or depleted uranium. Depleted uranium is chosen because, besides being very dense, it has a unique property. Instead of flattening when it hits metal like most materials, it actually sharpens during penetration. That means the deeper it goes into the armor, the sharper it becomes, helping it pierce deeper and deeper layers. When this projectile hits an enemy tank, it doesn't explode on the outside. It punches through the armor, and all the heated and fragmented material that enters with it causes massive internal destruction. Now let's talk about the tracks, which solve a physics problem that ordinary wheels could never handle. A modern tank weighs between 60 and 70 tons. If it had wheels like a truck, those wheels would immediately sink into any ground that isn't perfectly solid asphalt. Tracks distribute that enormous weight across a much larger contact area with the ground. It's the same principle as skis in snow. A person standing normally sinks. The same person wearing skis glides across the surface because the weight is spread out. Because of tracks, a tank can cross deep mud, snow, rocky terrain, and obstacles that would be completely impossible for any vehicle with conventional wheels. Inside, a modern tank is operated by a crew of 3 or 4 people. There is the commander, who coordinates everything and identifies targets, the gunner, who operates the cannon, the driver, who sits in an almost lying position at the front of the vehicle. And in some models, there is also a loader responsible for manually inserting the shells into the cannon. In more modern tanks, this loader has been replaced by a mechanical auto-loading system that selects and inserts the projectile without needing a human, reducing the crew and allowing for a smaller turret. In other words, a modern tank is not simply a brute machine of destruction. It is a highly sophisticated and precise engineering system where every detail from the composition of the armor to the shape of the projectile was designed to solve very specific physical problems. And all of this has been developed within a constant technological race where every new advance in attack always demands a new advance in defense with no end in sight.